Hi, my name is Matthew Mori, and today I want to talk to you about something very important in life: sleep. 100% of the world's population needs sleep. Without sleep, there could be ramifications mentally and physically. So why don't we sit down and learn a little bit more. So a few of the most common sleep disorders include sleep apnea, restless leg syndrome, narcolepsy, and insomnia. These sleep disorders are the most common and the most detrimental to a person's health. For our project, we decided that we wanted to make a sleep monitoring device that would be low in cost as well as provide all the vital information to help diagnose and remedy any sleep disorders.
To start, the user implements the various sensors. In practice, the body position sensors are placed on the back and both sides of the torso, the gas belt is placed around the waist, and the pulse oximeter is placed on the index finger. For the purposes of this demonstration video, we have placed the pressure sensors on a labeled piece of cardboard to show how the system acquires the data from the sensors. Once the sensors are implemented, the user starts the program and is prompted to enter the maximum and minimum values for their heart rate, breathing rate, and O2 saturation. This creates a range of acceptable values that the system continuously checks the measured values against. Once they finish that input, they are prompted with another dialog box asking them to select which metrics they would like to set an alarm for. As you can see, their options include all four body positions, heart rate, breathing rate, and O2 saturation. The first notable feature we are proud of is the alarm. The alarm system runs through a multitude of cases. From when the DAC begins to when it ends, the system is constantly checking the user-chosen alarm settings for a match from the physical sensors. It checks whether or not the O2 set, heart rate, and breathing rate are staying within the threshold values, and whether the sensors for unwanted body positions are being activated. If the values fall out of threshold, or if the unwanted body position is activated, the system switches to a case where it checks if the rates or positions remain at the unwanted values for the alarm threshold time. If at any time before the threshold time is met the sensor input changes to acceptable values, the system reverts to the checking for match stage from before. If the sensor inputs, on the other hand, stay at the unacceptable values, then the system moves to an alarm stage at which the time dialog box pops up. During data acquisition, average values for the numeric metrics are displayed on the main front panel, as well as the array of LEDs that indicate which body position they are in. The user has the option to temporarily suspend data acquisition via the pause function. They can restart the data acquisition by unclicking the pause button, and the system will continue to acquire data within the same study. When a user is ready to stop the data acquisition, they press the stop button. At this point, 4 separate waveform graphs display the data from the entire night, and a diagnostic summary pops up with the average values during the duration of the study. Concurrently, the system saves images of the 4 graphs as well as a copy of the diagnostic summary to the diagnostic data folder in the current file directory. The specified numeric data in an Excel file is saved to a user-specified location via a dialog box. The user is then prompted to shut down the system, and the system ends. The second feature that we are particularly proud of is the body position feature. The 4 body positions, left, right, back, and stomach, are recorded throughout the DAC using booleans. The physical sensors are 3 pressure sensors, each one on the left, right, and back of the user's body. When any of the 3 sensors are activated, the program reads the value of the sensor as a boolean true. However, when all 3 sensors are non-activated, the system assumes that the user is on his or her stomach, leading to a boolean true for the stomach. Thank you for watching this short presentation on our project. I hope you enjoyed it, and we'll see you around.